Alrighty, now that we reviewed how to solve a linear and a quadratic equation from algebra, we're going to relate this to trig. It's the same concept, only this time you're not trying to get x by itself. What you're trying to do when you solve a trig equation is get the trig function, whether it's sine x, cosine x, cosecant x, tangent x, by itself. And then to find the missing angle for x, we'll have to do an inverse. So that's how everything ties in. Now, on your homework, you have to read directions. For our first examples, I'm going to do 1a and 1c. The directions say to give the answers in between 0 and 2 pi. And that means they want every answer in radian measure. So again, we better pay attention. 9 times out of 10, you know how to work the problem. You just give the answer in the wrong notation. So for 1a and 1c, when we solve these and we get our answers, we're going to be given our answers in radian measure. Okay. Here is our equation 1a. Here is our equation 1c. First thing you need to do is make a decision, linear or quadratic. Linear means the exponent would be 1 with the trig function. Quadratic means the exponent would be 2 with the trig function. So if we look at here, our function is cotangent x. I don't see an exponent. It must be a 1. This is linear. On 1c, this has got to be quadratic. I have cosine squared. That's the first and most important thing. If you don't decide whether it's linear or quadratic, you have no clue where to even begin solving. All right, linear is easy. Linear means get the x on the left, move the numbers to the right. In trig, linear means get the function on the left, move the numbers to the right. So my job here is to get cotangent x by itself. Well, that's easy. I'll move 1 by subtracting it. So I'll get 2 cotangent x, this is going to cancel, we moved it, equals -2. Is our trig function by itself yet? No. We're going to divide by 2, divide by 2. And we're going to get cotangent x equals -2 divided by 2 is -1. So far, so good? Awesome. Guys, now here's the problem. You're not done. Your job is to solve for x. Talk to me. Think. Can I just take that word COT and move it over here by dividing? No. Remember, in trig, a trig function is connected to an angle. This x is representing your angle. So guys, to get x by itself, you can't just take the word cot off. To get a trig function, to get a trig equation, to get the answer to it, the last thing you have to do is an inverse. And this is what the tie-in is. I want to know what x is. I want to know what my angle is. If I want my angle, I need to do an inverse. You're giving me the number. So what you're telling me is x equals the inverse of cotangent -1. That's what you're doing. Okay? Do not do anything crazy on your paper and divide by cot. You can't separate the trig word from the angle. This statement right here is I'm trying to solve for x. X is an angle. If I want an angle and you're giving me a number, Miss Black, you must be asking me to do the inverse. Now here we go. No calculators. We don't need a calculator. First thing we're going to try is we're going to try to do the cotangent inverse of -1. Oh my, it's negative. So we need to know our principal values for cotangent. Okay, if cotangent's negative, okay, our angle's not going to be in quadrant 1. If cotangent's negative, I'm either in quadrants 2 or 4, right? According to principal values, it would be quadrant 2. All right. Which reference do we look that up on? All right, well, we have our unit circle. Oh, our buddies, the unit circle. And then I have my 30-degree triangle. I have my 45-degree triangle. And I have my 60-degree triangle. All right, so let's talk. If I give you the number -1 and I want the cotangent value, what's your definition? Cotangent is x over y. So let's go to the unit circle. If I take my x value and divide it by my y value, is there any way when I divide the coordinates on the unit circle, can I get out a negative number? No. Because if I divide 0 by 1, I get 0. If I divide 1 by 0, I get undefined. So I know it's not coming off the unit circle. It's not quadrantal. All right, if I do x over y for 30 degrees, would I get 1? Nope. For 45 degrees, if I do x over y, yep, I get 1. So I now know this reference angle would be 45 degrees. But it's negative. So I can't have that angle because I know it's not in quadrant 1. Now, here's the difference between section 6.1 and section 6.2. Section 6.1, when we evaluate a trig inverse, they don't give us a restriction on where to put the answer. They just tell us in section 6.1, when we evaluate a trig inverse, whether to put the answer in degrees or radians. In solving equations, this next section, there is a restriction to where they want the answer. And they're saying they want not just one angle, they want every angle between 0 and 2 pi. So they want every answer, every angle where the cotangent value could be negative. So yes, if cotangent's negative, the angle can't be 45 degrees. That would be in quadrant 1. What quadrants are cotangent negative in? Well, according to all students take calculus, cotangent would be negative in quadrant 2. It wouldn't be 3 because t is tangent and they go together. It'd also be quadrant 4. Now, I know if we do this in the calculator, we do the inverse of cotangent, and I don't give you a restriction, you would always give me the angle in quadrant 2. So we know if 45 is the reference angle, 180 minus 45 is 135 degrees. So in section 6.1, when we were just evaluating trig inverses, we weren't solving equations yet, we were just evaluating. Anytime the answer was negative, we had to memorize the principal values to know which quadrant the one angle had to be given in. Now, because we're solving equations, they're saying they want all the answers between 0 and 2 pi. Well, I agree. 135 is between 0 and 2 pi. But guys, an angle in quadrant 4 is also between 0 and 2 pi. So when we solve equations, there's not just going to always be one answer, even though it started out as a linear equation. They want the answers in all the quadrants. So if the reference angle is 45, in quadrant 4, the reference angle would be 360 minus 45, which is 315 degrees. So there's the difference between section 6.1 and section 6.2. When we're just evaluating trig inverse expressions, you always give one angle measurement. You know if the number's positive, if the angle's always in quadrant 1. You know if the number's negative, you'd have to look at the principal values. When we're solving equations, they're going to give a condition, a restriction. They want the answers between 0 and 2 pi, which is between 0 and 360. Well, if you start at 0 and go to 360, you're covering all 4 quadrants. So they want to know the angle measurements between quadrant 1 all the way through to quadrant 4 that make cotangent negative. One would be in quadrant 2, one would be in quadrant 4. But you're still not done. 0 to 2 pi means the answer's got to be given in radians. So we know how to do this quickly. 45 degrees was our reference angle. That's pi over 4. How many 45s make 135? 3. So your first answer for this equation is 3 pi over 4. 315 was made from 45, so 45 is pi over 4. How many times do you add 45 to make 315? 7. So that other answer is 7 pi over 4. That is the answer. You have 2 answers here to this trig linear equation. Now, I know that's crazy because it's trig and it was linear, and you're thinking linear should have one answer, but no. Because it's trig, and a trig function can be negative in 2 different quadrants, you have to give both. Okay? All right, let's look at C. Now, you told me this was a trig equation that was quadratic, and I agree. I see a square. So if it's quadratic, we got to make a decision. Do we set it equal to 0 to factor it, or do we do the square root method? Well, if you look, it's already set equal to 0, so it's ready to factor. Now, I know what happens here. You all get so confused because it looks scary. Guys, look at me. cover up the word cos and just look at it as algebra. Instead of this being cosine squared x, this is just x squared. Just pretend that was an x squared. Instead of being 2 cosine, that's probably just 2x. Plus 1 equals 0. So forget the trig words there. This is just x squared. This is just 2x plus 1. You all know how to factor that. It's a trinomial. You would do backwards FOIL. You would say what times itself is x squared, x and x. What can multiply to 1 and add to 2? 1 and 1 can. And to add to positive 2, they'd both be positive. It's the same rule here. This is what makes it algebra. You're thinking abstractly. It's the same rule. 3 terms, trinomial. What multiplies to cosine squared? It can only be cosine x times cosine x. What's the only thing that can multiply to 1? 1 times 1. Will your outers and your inners add to 2 cosine x? Sure they will. 1 cosine x and 1 cosine x would add to 2 cosine x. Now it's linear. You take both equations, you set them equal to 0. There's no need to solve both of them because they're the same equation. So we're trying to isolate the trig word. It's not by itself yet. We move the 1, and now we get it isolated. Cosine x is negative 1. But you're not done. You're trying to find x. You can't take the word cos and move it over by dividing. What you're going to do is I'm finding x. X is an angle. To find an angle, I'm using the concept of inverse. So x would be, if I do the cosine inverse of negative 1. Okay, I'm giving you the number, negative 1. I want out an angle. So now we got to figure out, where do we get a cosine value in negative 1? Well, we know cosine is x over r. If cosine's negative, can our angle be in quadrant 1? No. If cosine's negative, our angle could either be in quadrants 2 or 3. Or it could be off the unit circle. So let's think. Can we use our triangles to get a cosine value that's positive 1? Well, if I put my finger on 60 and I do cosine, x over r, that's a half. Put my finger on 45 and do cosine, x over r, that's 1 over square root of 2. Put it on 30, x over r is square root of 3 over 2. So there's no way to use our triangles to get a value of 1 for cosine. So that means this must come off the unit circle. So if I go to the unit circle, cosine is x. The only cosine value that is negative is right here at 180 degrees. So we don't have to worry about what quadrant we're in because this angle is 180 degrees. It's a quadrantal. But because of our restriction, here it has to be written in radians, which is pi. Is pi between 0 and 2 pi? Yes, it is. There we go. Everybody's okay? All right, great. Let's try 2 more in the notes. Okay? Let's go to the next section. So let me erase. All right, let's go to this example 2a. The equation is, I want you to solve 2 tangent squared theta sine theta minus tangent squared theta equals 0. So again, they don't have to use x. I know we're used to when solving equations using x, but they can use theta. The first thing I want you to notice is the difference in the directions. The directions say give me an answer from 0 to 360 degrees. So they're saying the answer is going to be in degrees now, not radians. Well, that's a relief. All right, I'm looking at this equation. It is obviously quadratic. I see tangent squared. To do factoring a quadratic, it has to be set equal to 0. It's done. The quadratic is already set equal to 0. So we have to factor this. This is not a trinomial. It is not 3 terms. All of this is connected by what operation, people? Multiplication. That's 1 term in math. It's 1 term minus 1 term. So it is not a trinomial. It is not difference of perfect squares like you all think. I know you see the difference sign. But guys, 2 is not a perfect square number. That's out. What you all seem to always miss is the first rule of factoring, which is GCF. What does this term and this term have in common that's the same? They both have in common a tangent squared. So I'm going to pull that out. And then you put in parentheses what's left when you take the tangent squared out. When I take it out, I'm left with 2 sine theta. And when I take that tangent squared out, tangent squared divided by tangent squared is -1. Remember, factoring means making multiplication. So when you're pulling it out, you're doing division. Now, I didn't move it to the different side. I didn't move anything to the other side by dividing. It's all on the same side, so I'm allowed to do that. What you've done now is you still have now 2 equations. You've now separated the trig function tangent from the trig function sine. See how they're together here? Now they're separated. This is technically in parentheses. And after you're done factoring, you're supposed to take each set of parentheses and set it equal to 0. So there's your first equation to solve. Here's your second equation to solve. Cool? Now, this equation is still quadratic. It has a square. It's set equal to 0. But can you factor this? No, this is one term. Tangent squared is in lowest terms. You can't break it down any further. So you learn the opposite of squaring is to do a square root. Squares and square roots cancel out. And that will leave us with tangent theta equals plus or minus the square root of 0, which is 0. Do we have to write a plus and minus in front of 0? Heck no. 0 is a neutral number. So this is just the tangent value is 0. Okay, if we come over here and solve, trying to get sine x by itself, sine theta by itself, we add 1. 2 sine theta equals 1. We divide by 2. Sine theta is a half. Everybody good? So that's my moral on this one, why I picked this one, because a lot of us missed that whole factoring rule GCF. But you're nowhere near done. Remember, you're solving a trig equation. Trig equations need angle measurements as answers. That's why we did the whole concept of inverse. You are no way allowed to take that word TAN and move it. You cannot separate the word from the angle. What you're doing is to find an angle, you're doing the inverse. So you're saying theta is the tangent inverse of that number 0. You're saying here, theta is the sine inverse of the number 1/2. And now we're going to look them up. If these were ugly numbers, long decimals, then yes, you would go in your calculator and do the inverse to get the angle. But these are all numbers that we don't need our calculators for. We know the only place we can find a 0 on is the unit circle. So if we go to our buddy, I love our buddy the unit circle for the 100th time, 1, 0, 0, 1, -1, 0, 0, -1. Okay? To get the tangent value to be 0, the definition of tangent is y over x. So if I divide y by x, I should get 0. So here we go. That's y. 0 divided by 1. Hey, that's 0. So 0 degrees would be an answer. 1 divided by 0. That's undefined. 0 divided by -1. That would still be 0. So 180 is an answer. -1 divided by 0 is undefined. So there are answers. We're not going to put this as 360 because you see the parentheses on 360? That means does not hit it. So if you remember from good old college algebra, brackets means you equal. So I could put 0 degrees as an answer. I can equal 0 degrees. But they don't want us to put it again 360. Even though y divided by x would be 360, we don't put it because there's a parenthesis there. Okay, so we have 2 answers right there. But we're not done. Now we got to do the sine inverse of a half. Well, by now we know a half is not on the unit circle. It's off either the 30 or 60. So I'm going to draw the 30 first. Sine is y over r. Put my finger on the 30. Y over r. Ah, yes, 30 degrees. But think, that's a positive number. Is sine just positive in quad 1? No. Sine is positive in quadrant 1 and also quadrant 2. So look, here's the difference. Today we're solving equations. And because of that, they're giving us a restriction. They want all the answers between 0 and 360. Just giving 30 is wrong because sine is positive in quadrant 2, and there's an angle in quadrant 2 that would spit out a half. What angle is that? It's the angle that's 180 minus 30, which is 150. In section 6.1, we weren't solving equations. That's why when we did the trig inverses and we were just doing evaluating, we only gave one angle because we were doing principal values. Now that we're solving equations, we don't need to do that. All right, I know. Let me do one more with you, okay, so we get it. Okay, so in your notes, the last one I want to look at is the next one because this one's very different. So we have 2 sine theta minus 1 equals cosecant theta. Okay, if I look at that equation, it's linear. I don't see a square. So if I don't see a square, I'm not thinking about factoring, which you can't. There's nothing in common to factor. You can't factor unless it's a quadratic. So it's linear. The problem with this is there's 2 different trig functions. That would be like me asking you guys, hey guys, take this equation, 2x minus 1 equals y, and solve it. You can't solve that. You can never solve one singular equation with 2 unknowns. Yeah, you could draw me a picture of that, great, because it has an x and a y, but that's not solving. When you solve an equation, you have to have all the same variable. Well, that's true in trig. If we can't factor this because it's not quadratic, we can't solve it right now because it's all got to be the same variable. So, oh my gosh, you ready for this? We're going to use our identities. Remember those 11 fundamental identities that I said in chapter 5 you needed to memorize? Here they come. You got to realize we got to rewrite this equation. We got to replace one of those trig expressions with what it equals. Now, in section 5.1, we said in trig, an expression is in lowest terms if it's in terms of what trig functions. That's right, sine and cosine. So guys, we're not going to take out the sine. We're going to love to leave that. Here's my question. What identity in chapter 5 can I replace cosecant with? That means the same thing as in terms of sine. That's right, you can use a reciprocal identity. So the left side we're going to leave. We are going to replace this with the reciprocal identity. Cosecant theta is really 1 over sine theta. Now that's a major achievement. You now have the equation all in terms of the same trig function. That's like having the equation all in terms of x. If this over here was an x, you'd be rocking and rolling and solving it, right? All right. So if you have a linear equation in trig, and you have more than one trig function, you're going to have to do a substitution. Okay? You want to have your trig equation all to be the same trig function to solve it. Now that we got this here, guys, we got a problem. We made a fraction in our equation. I don't know about you, but I always teach my people in Algebra 1 and Algebra 2 in college algebra. I don't like fractions in equations, so I get rid of them. To get rid of a fraction, you do the opposite. This bar means division. So to get rid of a divide by sign, I multiply by sign. But if I do it to the right, I got to do it to the left to keep balance. And here we go. What is sine theta times 2 sine theta? That would be 2 sine squared theta. What is sine theta times negative 1? That would be negative sine theta. What happens when you multiply by sine theta and divide by sine theta? Those are opposite operations. They cancel out. There's your equation now. No more fraction. What do you notice? Oh my, it's quadratic. So if it's quadratic, the question is, do I set it equal to 0 and factor it, or I do the square root method? You should all be able to look at this and say, no way for square root. Because if you do the square root method, you're supposed to isolate that term only. And if that term is supposed to be by itself, if you move the sign over here, you can't take the square root of sine theta. So the square root method doesn't work here. This is factoring. So we set it equal to 0, we subtract 1. We get 2 sine squared theta minus sine theta minus 1 equals 0. Okay, these are all unlike terms. None of them are alike. We put them into correct descending order. I know what you're thinking. I don't know how to factor this. Yes, you do. There are 3 terms here. 1, 2, 3. This is a trinomial. It's backwards FOIL. Now, if that confuses the crap out of you, everywhere you see the word sign, put an X. So I'm going to write it as it would look in algebra. This is really 2. Forget the sine theta, put an X squared. Minus, forget the sine theta, put an X. Minus 1 equals 0. Factor that, and then you could write it as trig. This is a trinomial. I'd put my 2 parentheses. I'd start with the first term. What multiplies to 2x squared? Well, that would be 2x times 1x. What multiplies to 1? Well, that's just 1 and 1. I want to subtract to make what's in the middle here, which is a negative 1x. Now, here's the problem. If you say subtract, these have got to be different signs. It matters who gets a negative sign. It matters who gets a positive sign. If I want to subtract to be negative 1, the outers are 2x, the inners are 1x. This has got to be the negative. I want a negative 2x and a positive 1x. That's factored now completely. I could check it by doing FOIL. First, 2x times x, 2x squared. Outers, 2x times negative 1. That'd be negative 2x. Inners, 1 times x is 1x. If I put these terms together, that gives me what's in the middle. Last, 1 times negative 1 is negative 1. Now that you got it factored, come back here. Don't put x anymore. We're using sine theta. So this would be 2 sine theta, and this would be sine theta. Positive 1, negative 1. Isn't that awesome? Now, we're not done. We set both of these equal to 0. Because every time you factor a quad, you get 2 linears. You solve. I'll move the 1 over by subtracting, and I'll divide by 2, and I'll get negative 1/2. I'll move the 1 over by adding. And now we're ready to pull in the inverse concept. Now that we got the trig function alone, now we're ready to find the actual answer, which is an angle theta. And they want it in degrees, which is awesome. We don't got to change the radians. But now we got to look up a sine value in negative 1/2 and a sine value of 1. Well, a sine value in negative 1/2 is not coming off the unit circle. It's got to come off a triangle. So if the sine value is negative off a triangle, we know we're in a quadrant. What quadrants is sine negative in? 3 and 4. All right, where do we get a 1/2? Well, it's not off the 45, 45, so it's either got to be off the 30 or the 60. So if I throw up again, here we go. There's my 30. If I do sine, sine is y over r. There's the 1/2. We know the sine of 30 degrees is a positive 1/2, so that's my reference angle. What would the angle be in quadrant 3? If you're in quadrant 3, you have to be bigger than 180. So 180 plus the 30, the reference angle would be 210. If you're in quadrant 4, the reference angle rule is 360 minus the reference angle. 360 minus 30 is 330 degrees. Everybody good? All right. If the sine value is 1, that's got to come off the unit circle. So if I look at my buddy the unit circle, sine is always y. Where is the y value? 1. Right there, and that's 90 degrees. So for this trig equation, there are 3 answers. Okay, so this is going to take some work. Okay, I don't expect you to look at the equation and just know the answers off the top of your head. I expect you to work this like algebra. I expect to see all the steps. You need to be writing all the steps so you understand what you're doing, because that's the whole concept here. Relate what you learned in college algebra to trigonometry. Understand, in order to solve a trig equation, because you're finding an angle measurement, you're using the concept of inverse. Okay, we have 2 more sections left, and all we're going to do now is some more difficult equations. I'll see you next video.